Good morning, good evening, good afternoon, boys and girls. It's time for another Cisco Packet Tracer Lab, and we are going to learn about IPv4 and IPv6 configuration with dual stack. So that's basically what we have prepared for today. Let's go over the lab. Let's try to understand it. First, let's go ahead and see this topology and try to see what we have there. We can actually validate in this scenario that there is a total of a router 1, a router 2, and a router 3. There is a total of 3 routers. We have a total of 3 PCs as well, and some switches. Switch 1, switch 2, and switch 3. SW3. Okay, so what is the idea? The idea is to configure most of the IPv4 and IPv6 in these routers. Maybe we might have to configure only the routers or the PCs. I don't think we have to configure the switches at this moment. So let's go ahead and read this lab. What is this lab about? Let me clear the drawings for a moment and let's go back. Basically, we're working on a network design to configure and verify dual stack IPv4 plus IPv6 routed network using Cisco Packet Tracer. This is the updated version that we currently have from an end-to-end perspective. So let's analyze the topology. We have some IP address there, some routers, some PCs. Looks like we are not configuring much in the switches, only the routers and the PCs for this scenario. So we are not doing, there is some validation and troubleshooting commands at the end of the section and some pin connectivity tests. So let's start with the configuration of the PC. Let me go there and let me start working on it. So we need to configure a static IP address. I will also share the Packet Tracer Lab with the completed version and the initial version. So I'm working on that right now. Give me just a moment. Have the completed version. It might take a moment so I can finally have it. And we have the initial version. Initial version. Okay, so let me work alone on this completed version so you can have everything done. And the first thing we do is essentially go to the PC and configure them. So let's go ahead and work on those. I'm going to duplicate this for a moment. And let me show you what we have here. We have, yes, we already went over this lab, but I'm missing something. Let me just duplicate it here. And this is actually switch 3 that we have there. So I'm going to save this to have it handy. Maybe I can actually update the topology, but it's not really necessary. We already know that the only missing thing was switch 3, the only missing piece of the puzzle. So let's go ahead and start with the PCs. Let's go to, let me close this one. Let's go to PC1 so we can add the configuration there. Let's go to desktop IP configuration, and from the document you can go to page 5. Go to page 5 and let's start adding the IP address 192.168.10.10. Then /24 for the subnet mask. And then we have 192 and 168 that I am 10.1. No DNS server is required this moment. Now we have to go with the IPv6 address. Let me just copy and paste it there. It's like 64. And what else are we missing? The default gateway. We need to add that default gateway. Let me just copy and paste it there. And there you go. We have PC1 completed. Next thing we do, we go to configure PC2. So we have 192 and 168.20.20/24, 192 and 168.20.1. Let me stop sharing the video for a moment so we can concentrate better. I need to copy the IP address for PC2, but this is the IPv6 address that I'm adding there. Copying that and pasting this information. Finally, we have the default gateway, which is in page 5 of the document. You can just copy and paste it from there. And we are done with PC2. Let's go with PC3. Let's go with PC3. Let's go to desktop IP configuration and let's start adding some IP addresses. We have 30.30 there, /24, 192 and 168.30.1. Let's go ahead and work on the IPv6 configuration here. Let me just copy and paste it there. This is a /64. And finally, we have the default gateway for the IPv6 address. We are pretty much done. Make sure you don't have any spaces there. And let's close this stuff. So we have configured the PCs. What is missing, boys and girls? What are we missing? Do you guys remember that when we were configuring the routers, the different routers? And I'm going to name those routers so we don't encounter any problems there. So let me work on that right now. Let me work on it. So the first router is the CE router. So let me just copy and paste it there. There you have it. Save the configuration. The second router is the PE router. So let me just change that. I'm using the graphical interface, so it's faster, but remember you have to do this via CLI if possible. And the PE router is there. Let me go to the last one, which is actually power off for some reason. I need to power this on. It might take a few seconds there, so let's just wait for a moment. The device is still booting. Please wait until it is finished. So for some reason, it's not letting us do anything. We need to wait, and finally we can do some work on it. So how do you configure the host name for this device? You go to config T, configure terminal, and then you execute host name, and then you paste that specific name. And there you have it. Let's do test one just for now, and let me just paste it there. There you have it. You can do a do WR to save the configuration, and that's pretty much it. Now, do you guys remember the faster way to configure those routers? So we went basically, I just want to P router, P router, P router. Yeah, great. So the first thing we do, and I'm going to open the Word document that we have there, so it's easier to copy and paste. We are going to look for the configuration of the C router. I'm just going to look it up there. The whole configuration. I'm going to open a notepad. Give me just a moment to validate something here. And paste that information there. Now, remember, we need to remove those spaces in order to avoid any issues when trying to copy and paste the whole configuration. Look what we are adding there. We are adding some IPv6 addresses, some IPv4 addresses, the routing protocol OSPF. We are still working with OSPF on this one. So I'm working on the first router. I'm just going to do a config T and paste the whole configuration there. There you do a do WR and we're pretty much done. Just do some validation that there is not errors when you are adding all of these configurations. We're pretty much fine. I don't see much errors. We can do a small test from the PC just to validate if the IP addresses are working. Maybe it will take a moment. So let's do real-time to simulations for the IP addresses and the conversions to fully complete it. If it is not working, maybe there is something wrong in the configuration, but it is successful now. So it means we have been doing things greatly. Okay, let's do the same process. Let's do the same process for the P router. Let's just copy and paste it in an output. Let's clear this with a supreme and let's clear all those spaces that are necessary. Let's remove all those spaces. So let me work on it. Okay, we're almost there. We need to remove the spaces. What are we missing, guys, boys and girls? Okay, just remove the spaces, copy everything here. Look at the IP routing command. IPv6 unicast routing is important, so the router recognizes the IPv6 integration that we are doing. So let's go ahead and copy this in the router too. Let's do a config T and paste it. Might take a few minutes, do a do WR. Let's see, why is not working? Okay, let's just do WR and that's it. Now we can do a ping test from router to router. And you can see it is working. We're going to do the IPv6 ping test connectivity later on. But for now, we're just focusing in IPv4 for now. So do not worry about the IPv6 section. We'll cover that in a moment. Finally, we have the P router. So just go to the Word document and copy and paste that configuration. And go to the notepad and paste everything there and start working on removing those spaces. Okay, be careful. We're just removing the unnecessary spaces there. Okay, Control Z. If you get that error, let's just remove those unnecessary spaces. Let me just copy this information and work to the router 3, the last router, which is actually called the P router. Let me paste this there. Let's do a WR just to cover our back, and we are done. The lab is now completed. Now, we're going to follow the instructions. With that being said, we're going to do some ping connectivity tests in PC1, PC2, and PC3. We are going to do IPv4 first and then IPv6. So let's start with that. Let me go ahead. I want to validate if we actually, within those configurations, did we configure OSPF version 3 for those devices or only OSPF version 2? Yes, we actually configure OSPF in the interfaces mainly. OSPF version 3 in the interfaces. Okay, so let's go ahead and validate the configuration. Let's do a show run so I can share with you where did we configure the OSPF in the interfaces. What do you guys think? You can see it right there in the section that says, let me validate here. Those are the IPv4, IPv6, IPv6 OSPF 1, area 0, and it should be there somewhere. Okay, there it is. The serial interface have OSPF integration, and the IPv6 address is there as well. So let me do the first test. Let's go ahead and go to PC1, command line prompt, and in the command prompt, in the CLI or command prompt, let's execute the first command, which is a ping test to 192.168.30.30. We are sending a ping all the way from PC1 to PC3. It might take a moment. Remember, the first one always give us a requested timeout, but if we execute it one more time, eventually it will work. Now we're going to send an IPv6 ping, should be the same. Let me just copy and paste that command. And you can see IPv6 is successfully working to PC3 as well. Let's go to another PC. Let's go to PC2 so we can run the test there. Let's run the first one. Let's do a ping to 192.168.10.10. There you go. And let me just copy and paste this IP address so we can do the same connectivity ping test. Remember, Control A, you can do at the ping. It's pretty much the same command. And the IP address, the IPv6 address, and everything is working like a charm. Verify the interfaces are shut down or not. Okay, how do we do that? Do you guys remember? Let's go to router 3. We can do show IP interface brief, and you can see most of the interfaces are up. Let's validate that real quick. Is everything up? Great. Okay, next thing we do the IPv6 unicast routing. We validate that one is configuring the routers. So with the show run command, you can actually see the IPv6 unicast routing right there. What else can we do? Okay, these are some troubleshooting commands. Let's apply for IPv6 and IPv4 in this specific router. So let's go ahead and paste it there. We have to remove those spaces that are not necessary. So let me just remove the spaces and paste it there. There you have the IPv6 addresses and they are up and functional. Now, the IPv4 was show IP interface brief, and that is pretty much the same, but for IPv4. So we have IPv6 and then IPv4. Now, next thing we do, show IPv6 OSPF neighbor. Show IPv6 OSPF neighbor, and there you have it, the neighbor. Are we seeing the neighbor per se with an IPv6 address? Not necessary. The information that we are seeing mainly is the neighbor IP. That is information that is displaying there. Now, let's do the same one, but only with show IP OSPF neighbor, and you can see pretty much the same information. What's the difference between those two, guys? It's pretty much the same information, but you can see that one is the IPv6 version and the other one is the IPv4 version. Let's do a show IPv6 route, and you can see all the routes in the routing table for IPv6. Now, if we do the same one, but we remove the v6, you can see IPv4 addresses. I want to see if there is like a two IP protocols and if we can see both IPv4 and IPv6. We can see pretty much IPv4, IPv6 protocols. Yes, look at that. We can see the two IPv4 and IPv6 protocols, but this one is with the show IP protocols command, and the other one is with the show IPv6 protocol command. You can see it is connected. The protocol is ND, OSPF1, there is 0, the serial interface, there is no redistribution, it's in area 0, and that's pretty much everything. Let's see if there is any additional commands that we can see. So how do we send a ping to one of those IP addresses? Let's see if we can send a ping to one of those IPs. Let's try with this one. Let me just copy and paste it and see if I just send a ping from this router to that specific PC, you can see it's successfully working. So we are sending a connectivity test, ICMP, from PC PC1 to the router. And this is actually going from the router 3 or P router to the PC1. Let's do it all the way from the PC to the router. Let's see if we can do it. We see in the envelope, we see a successful connection, but how do you guys do this in real life? If you don't have packet tracer and you have to test it in real life. So we have to ping the default gateway for router 3. Do you guys remember in the router table, what was it? What was the default gateway for this specific router? Do you guys know? Okay, let's look it up. Is the P router, the IPv6 IP address is actually this one. Let me just copy and paste it there. Let's do a connectivity ping test. And let's wait for a moment. You can see it is effectively working, successfully working. We are sending pings through. I think we're pretty much done with the lab. Let me just save the configurations there. And you will be having those labs. The packet tracer lab for the configuration with no devices per se, devices with not configuration, my mistake, and the devices with the configuration when it is actually completed. This can be acquired at my Hotmart CCNA complete course. It should be cheap. If you just talk to me, I can make you a discount and you can just buy the whole complete course for the CCNA certification exam. So, boys and girls, it's been a pleasure. I will see you at the top of success. And until next class, goodbye. I will see you around.